Okay, so we are discussing threads. Let's do a 5-minute recap and then continue. So yeah, so we have discussed that. I mean, till before yesterday, we considered a process with a single thread of execution. That means there was one program counter, let's say, with a particular value of the program counter and registers and stack, etc. And a process had its PID. But yesterday we have started discussing about threads. So now we understand that a process can have multiple threads of control. And often these threads are used to do tasks. I should not use the word parallel because again it's a uniprocessor system. So, I mean, there is actually not parallelism because only, still, I mean, like one thread or one process can execute at a time. Still, I mean, applications or processes use threads to make it feel like multiple things are being done parallelly. Like say, when we load a web page, say some pictures are loading, as well as maybe on the same page you have to log in. So one thread is waiting for your login, whereas in the background other images are loading. These things happen. So just to create this illusion that things are happening in parallel, often processes use threads. And so each thread has a unique thread ID. And this is important that each thread has its own program counter, register set and stack. And this is why each thread is a thread of execution. Okay? So basically a program counter, register set, stack, these define till what has the program been executed, after this which instruction is to be executed and so on. So this is what is unique to each thread. Also, all threads from the same process share the code section, data section, and other OS resources like open files. So essentially, all threads of the same process share the same virtual memory address space. So this is the picture that we showed. Like in a single threaded process, there is only one copy of, say, the registers and stack, and code segment, data segment, file, open files. This we have discussed earlier. Now in a multi-threaded process, see the code segment, data segment, open files, there is only one copy shared among all threads of the same process. However, each thread has its own registers and stack. Registers would include the program counter, different variables, or variables might be in the stack, but yeah, the other registers. So essentially all threads are sharing the data segment. That means, say, if you have any global variables, that will automatically be shared among all threads. Or all threads will share the code segments and the same code. However, each thread has its own registers and stack, which allows it to form a new thread, a unique thread of execution. Okay. Then we discussed our practical applications of threads. So one major practical application is threads are much more efficient than processes. So say creating a process takes a lot of effort on the part of the kernel because the whole address space has to be copied, and we have discussed this while discussing forking. But in case of a thread, creating a new thread, it's much cheaper in the terms of the resources used or the time needed, or say how many kernel operations have to be executed. So in those terms, creation of a thread is much cheaper because the code data they will automatically be shared. So basically only this part needs to be replicated, register, stack, and so on, right? And that too in the same virtual address space. By the way, this virtual address is not possibly understood yet. We will discuss this in detail in the later part of the course. Okay. So then we discussed some practical applications of threads, and then we understood that there are multiple ways of mapping user level threads to kernel level threads, like many to one, one to many. Sorry, it won't be a one to many, but many to one to one, or many to many. Yes. Okay. So today we will start some actual programming, as in how to program threads. We will show you some code snippets and so on. So there are many different thread libraries. Like Windows has its own thread library. I think Java has its thread library. We will discuss a particular thread library called POSIX, the thread library. The actual name of the library is pthread. POSIX is a standard. Let's see. So, so first of all, what is a thread library? Essentially, just like you have used C standard library, something like that. So the thread library provides the programmer with an API for creating and managing threads. So, for example, just like printf scanf, like you don't have to do the actual system calls which are needed to create threads or manage threads. You can do some function calls which on your behalf will call the system calls. So it's that kind of a thread library. So there are two ways of implementing a thread library. Remember, most of it we will discuss about using the library, that will come. But just a couple of points about the implementation of the library itself. That means the people who designed this library, they have two choices. One is to provide the library in the user space. That means all code and data structures of the library exist in user space, and they call system calls. The second option is to provide a kernel level library. That means the code and data structures of the library exist in the kernel space itself. And whenever you invoke a library function, it results in a system call directly. So in both cases, finally a system call will be invoked. But the question is whether your calling a library function directly involves a system call, or whether you call a library function and that library function on your behalf calls a system call. So usually the first choice is more popular. But yeah, I mean, there are enough, sure, there are examples of kernel level libraries also. So anyway, so as I said, there are several different popular thread libraries. Windows has its own, Java has its own. We will discuss mainly POSIX pthreads. Okay. But before beginning that, just one other point. Essentially, there are two strategies for using threads: asynchronous and synchronous. What is the difference? Let's see. So in asynchronous threading, the parent thread creates one or more child threads and then resumes execution. And parent and child threads execute concurrently. That means each thread runs independent of others. And parent did not know when child thread terminates. This situation is mostly used when there is not much data sharing between the threads. That means the parent has created a child, but then the child will do something independently. The parent is not at all dependent on the child or vice versa. So this, I guess you have come across such situations, if not using threads, using processes. So in your networks course, you have designed library servers. So that is one example where the parent thread, like every time there is a new connection request, maybe the parent thread creates a child thread to handle that request. But the parent, after this, does not worry about that thread. The parent goes on listening at the socket, right? And the child thread is expected to handle the connection request and deal with the user independently. So such examples are that of asynchronous threading. In contrast, we can have synchronous threading. So the parent thread creates one or more child threads and then waits for all child threads to terminate before it resumes. This is also called fork join strategy. So typically, this situation is used when the parent actually needs some service from the threads and there is significant data sharing among the threads. Say for example, you have to do some operation on a huge array. So doing that operation for every array element sequentially would be tough. Would be take more time maybe. Therefore, you create some threads which do that. Do those operations again, like within quotes in parallel. Actually, we know that it is not parallel, like it's all concurrent. But yeah, you might get that feeling that okay, multiple things are going on together. So yeah, for these cases, the parent actually has to wait before the operation has been completed by all threads. Therefore, this is called synchronous threading, where usually the parent is like in synchrony with the children. So it's waiting for the children or something like that. I mean, the parent wants to synchronize its own working with that of the child threads. Okay, so now let's discuss about the POSIX library, the pthreads library, I should say. So just to clarify, the pthreads is the actual library. POSIX is just a standard, or it's a family of standards. So POSIX, the full form is Portable Operating System Interface. It is a family of standards for maintaining OS compatibility. So basically, it tells the OS what function calls need to be supported. So I think all of you know that there are some different flavors even within Unix or Linux. Right, so suppose someone is developing a new flavor of Linux or a new distribution. If they say that they follow the POSIX step, okay, so I think I understand that the idea is that maybe someone is developing a new Unix or Linux version, a distribution. Now, many people have already written programs in older distributions. So this person who is designing the new distribution would definitely like programs already written for other distributions to run on this new distribution. Otherwise, no one will buy it. Like, I hope this part has nothing to do with OS. This is economics. Like, suppose you create a great system which is very efficient than all other previous systems and so on. But then you say that, okay, this system is completely different. So whatever programs you have written or whatever you have done with the previous systems will not work here. Then however good your system is, not many people would be willing to switch. Because they will say, hey, we were using the new system, we were happy with it. We had learned how to use it. Now suddenly you are telling me I have to completely unlearn that and learn your new system and none of my programs written earlier would work. I am not interested. I mean, I'm fine with what I had. Okay. So therefore, it is in your benefit that you design the system so that it is compatible with what has been done earlier. What is this feature technically called? This feature of making a system somewhat similar to previous versions or existing versions. Okay, standardization is definitely one term. That is exactly what we are discussing. Any other term comes to your mind? Like, say, when a new version is being created, a new version of a same software is being created, whereas people have been using older versions. We want the new version to be something. Exactly. Good, Jayant, yes. We want a new version to be backward compatible. That means whatever has been done using previous, all programs written using previous versions should also work on this version. Okay, so that is backwards compatibility. So we want this. I mean, sure, consumers want this, and from a producer point of view or from a designer point of view, if you don't provide these features like standardization and backward compatibility, maybe your product won't sell much because no one likes to again take the burden of learning everything to newly and so on. Okay, so POSIX actually helps in standardization, and okay, in part like backward compatibility also, because yeah, new versions also should obey the POSIX standard. So basically, it tells the standards for maintaining OS compatibility. So essentially, it tells the OS what functions need to be supported. How you support that you can change, but the API should remain the same, so that when when user programs call your functions in the API, they should get the same service. Internally, how you implement the function, that you might change. So that is the idea of an API. Okay, and POSIX says that, okay, may be provided either as a user level or kernel level library. Right, and all major thread libraries in Unix are POSIX compatible. I mean, pthreads is not the only like thread library in Unix. It is possibly the most popular, that is why we are discussing it. But there are other thread libraries in Unix also. But all of them are, I mean, at least the major ones are POSIX compatible. So how to run program, how to write programs? Include pthread.h in the main source file, it is header file, and you have to link this library while compiling. Right. So -l pthread, so you have to link this library. And the semantics is as follows: any data you declare globally that can be directly accessed or shared among all threads of the same process. And whatever you discuss locally, that means inside a function, data local to a function, that is, we know that that is usually stored in a stack, and each thread has its own stack. Therefore, each thread has its own copy of the local variables. Also, threads begin execution in a specified function. We will see some examples now. I mean, we will see an example code. So the example code is very simple, as in the application. This is just for demonstration, so we are not doing anything very practical. But in the example that we will study, there will be a parent thread or a process which will create a thread that calculates the sum of n natural numbers, where n is an input. And the parent thread waits for the child thread to terminate. Again, like I'm giving this disclaimer, this is not a very practical situation. Of course, like you use threads for much more practical applications than this, but this is just for demonstrating the codes. And again, I will discuss some of the code, some of the function names, maybe some parts of it. But again, we expect you to look up the man page or some resources on the internet to know a bit more details about the functions. Okay, so let's actually discuss the code. So yeah, include pthread.h, and then see, we declare a global variable sum. So this is the data that is shared over all threads, and we declare a function void star runner void star param. Okay. So this runner is the function. This runner is the function which the threads will run. Let's see. So essentially we will have two functions in the program. One is main, the other is this runner, right? And we will use a particular call to, use a particular mechanism to tell the kernel that whatever threads are created, they should start executing this function. Okay, so threads won't execute the main function. The main function is the parent, like the parent thread that is executing. We will create threads inside main, and we will use a mechanism to tell the kernel that all threads created should start executing this runner function. By the way, you can change this, of course. Like in this very simple example, we have written just one function and all threads execute this function. But in a practical scenario, you won't do that. You will have several functions and possibly different threads will execute different functions. So that you have a mechanism to tell the kernel that which thread will execute which function. So here are some variables that need to be declared. One is this pthread underscore t. This is a data type which will store the process, the identifier of the thread that we will create. Okay. So what do you think pthread t is? Like what is it? An integer, float? What do you think it is? Okay, Nisarg says it's an integer. Any other opinions? Okay, Jan says it's a structure. Yes. Okay. From intuition, I think also this is a structure. Because sure, it's an identifier, but I mean, though, okay, I'm not, okay, let me see once. Can we actually look this up? Okay. Okay, this do not deal with pthreads. Okay, I mean this do not deal with pthread underscore t, and I don't think this will have an entry. This is not a function. No, okay, fine. Yeah, pthread t is not a function. Okay, pthread t. So I guess we should check the internet once. Pthread underscore t. Okay. In many threads implementation, the pthread underscore structure is an integer. Ah, okay. That it's just the integer. Then I would imagine that the pthread, okay, the next structure would be used for, okay. I see. So both are okay, I guess. So if you see, I hope you can see this line. So in some thread implementations, the pthread abstract type is implemented as an integer. But in the IBM implementation of pthreads, the thread ID is a 64 integral value, and the pthread underscore t is an abstraction, a structure that contains that value and others. Okay. Okay, and it says, do not allow your program to rely on the internal structure or size of the pthread underscore t in an automutable fashion. So, I mean, do not assume it's an integer so that you just say you have to compare between two threads whether they are equal. It clearly says that do not depend on pthread underscore t to be an integer or a structure, whatever. So use, there are particular functions given like pthread underscore equal, which will ensure portability in your code. Right? Okay, so see again, this is one thing which, I mean, I also did not know that some, at least from this page it seems that some pthread libraries, or some thread libraries, in some pthread libraries, because pthread again, pthread is just, I mean, the POSIX standard. Many libraries can implement the POSIX standard. Some of those libraries, it seems, implement pthread underscore t as an integer for byte. However, IBM implementation of pthreads, it has, I mean, implemented pthread underscore t as a structure that contains a thread ID, a 64-bit integer, plus something else. Okay. Okay, so coming back. Yeah, okay. So pthread underscore t Okay, yeah, Ravi also tells the same thing from Stack Overflow. The pthread underscore t type is an opaque type. You are not supposed to know what it really is. So if you are writing the program, you do not need to worry about how pthread underscore t is implemented. That is an internal detail of the library. But again, you should not assume it's an integer. For you, pthread underscore t is a data type, right? So you should consider that as like maybe whether it's a structure or an integer, you should not write your programs assuming that. Okay, so pthread underscore t TID, that is the thread ID that we will identify for the thread that we will create. And this is a structure which stores the attributes of the thread. So a thread also has different attributes. That is stored in here. And pthread attr init, this is a function call to fill this structure with the default attributes. Okay, so this is, so see, we have not yet created the thread, we will, but this is, we just are making things work so that we want to create a thread with the default attributes. Okay, so this is the preparation part. Now let us actually create the thread. Pthread underscore create, this is actually creating the thread. Okay, so if you see, it takes these arguments, the thread ID, the address of the thread ID, and also the address of this structure which we created. Okay, and then you have this runner. What is this runner actually? So we understand it is the name of this function. Yes, this is how we are telling the kernel that the new thread that will be created should start running from this function runner. But what is it actually? What is this runner? In terms of C programming language, what is runner? Exactly what Deep mentioned. Good. Runner is a function pointer. Okay, so the name of the function is a function pointer. So hopefully you are aware of function pointers. If not, please look it up. Okay, so Deep, maybe unmute yourself. Can you give some other example of function pointer apart from this? Where is it used?
Sir, in QSort.
Good. Elaborate a bit.
So for QSort, it takes
So
it takes
QSort
an array and a function pointer which compares elements, and that
Mhm.
function pointer is of a function that takes two elements and returns an integer.
Right.
Negative for less, 0 for equal, greater than, positive for greater. So yeah, QSort takes that as a function pointer.
Exactly, very good. Just to explain, think about this. Again, I don't know how many of you are aware of function pointers. Hopefully everyone is, but just to explain, function pointers are used when you have to tell some other function to use your own function. So for example, quicksort, actually if you don't need to write quicksort, you have written in your PDS lab maybe, or yeah, but actually you don't need to write it, at least in Linux, because Linux gives its own implementation of qsort. So the thing is, the quicksort algorithm is well known. The kernel does, Linux already has not kernel, but Linux already has an implementation of it. But then, the designers of the kernel, they could have written a quicksort assuming that you will only sort integers. They could have done that. But then it would not have been so useful, because you may have to sort your own data types. So what they did is, they said, okay, see, the quicksort algorithm, you don't need to tell them, they also know the quicksort algorithm. The specific thing that you need to tell them is how to compare between two of your elements. Let's say your two elements are two structures. Okay, think about the IIT entrance exam, IIT JEE. So there, in order to compare between two students, a huge algorithm is there, because ties need to be broken. So maybe if the total is equal, then look at something, maybe physics marks first. If that is also equal, look at chemistry marks. If that is also equal, look at math marks. I'm just making up things. I'm not claiming these are the rules. But yeah, I mean, there is a complex rule to decide whether, I mean, how to compare between two students in this case in order to create that sorted list or ranked list, right? So, and that is, I mean, this happens not only in academics but also in, say, sports. Like in sports, when many teams are playing a league, how will that table be shown? Who is at position 4 and who is at position 5? Let's say if it is a cricket league, then there is a complex algorithm. Like if the points are different, then fine, easy. But if two teams are in the same point, then look at maybe their net run rate. If that is also equal, look at who, when these two teams played, who won, and so on and so forth. So comparing two elements is not easy. Like we always write in our labs, we write programs using integers, but in reality, you can actually apply sort on, say, structures or complex data types where you need to define how to compare between two elements. So the designers of the QSort, the designers of Unix, they have given a QSort function where you need to tell QSort how to compare between two elements. How will you do that? You will write your own compare function and send a function pointer to QSort. You can look up man QSort. Okay. Here also, coming back to pthread create, the idea is similar. You have written your own function which you want the thread to execute. You will send the function pointer of that function to pthread create. So when kernel will create that thread, it will know from what to start that thread. So understand the difference. When we created processes, we said that, I mean, fork creates a completely new process. The process starts executing right at the next line after fork. So nothing to tell actually. That is the semantics of fork. Every new process that is forked will start executing from that line after fork. But in case of thread, we actually want different threads to do different things. Therefore, you are allowed to write different functions and then indicate to the kernel that this thread will execute this function. Okay, so this is how we create a thread. And then we call this example calls pthread join. This is indicating that the parent thread wants to wait for the child thread to exit. This is the fork join strategy. Again, whether you use it or not depends completely on your application. But pthread underscore join is used for waiting for the thread to exit. Finally, when the thread has done its job, we expect that this global variable sum will contain the input and will contain the sum, so we print it out. Again, understand that the sum is a global variable, so all threads should be able to access this. Finally, let's look at this runner function itself. This is kind of simple. So int I, okay, this should be a small, lowercase I, sorry. And then we have this parameter as a void pointer. So we need to typecast that into whatever we want it to. So we have got an integer, and then we sum first n elements, and then this function calls pthread exit 0. So pthread exit is terminating the thread. Okay. Once this is executed, that means this thread has terminated. So this pthread join will now, so this blocked the parent thread because the parent thread wanted to wait for the child thread to execute. So when the child thread calls pthread exit, then the parent thread will again be ready to resume. Okay, and then it will print the sum, and then yeah. So any questions about this code? Okay, if not, we will see just another example where, so this example, this very simple example creates just one thread. We will see another example of the same application, but where multiple threads will be created. So what do you think intuitively would be the differences? Intuitively, I'm not asking for details, but what would you expect? If one can, for this question, if someone has an answer, we can unmute and say. The same program, if we want multiple threads, what changes would you intuitively expect?
Add a loop.
Sorry?
We have to add a loop.
Okay, yes, add a loop. Anything else?
So I need to protect access to like shared variables.
Sorry?
I mean, we need to make sure that there are no data races.
There are no data?
Races.
Race, okay.
Recommendation.
Wait. See, we are not going into those things right now. We will discuss about, I mean, the next topic would be about avoiding race conditions, etc., etc. But we are not thinking of those things. I mean, I'm just asking in the data structures of this program, what changes do you think would be needed? I'm not introducing more complexity here. So race conditions, etc., don't worry about them right now. Some changes should be too intuitive, right? Okay, this I expected to get an answer, as in, see here we are declaring structures to store the attributes of one thread. If I want 10 threads, need to have 10 such structures. Okay, so yeah, I mean, basically what we will see is we will now have arrays of structures. And of course we will have a loop. So okay, so let's see now. Let's see the code. Okay, so yeah, so see we are hash defining something called NTHR. This is just the number of threads, 10. So we are going to create 10 threads. So see now this difference is that in this pthread T, we have an array. Okay, so we are preparing for 10 threads. And yes, we run a loop where pthread create. Now we give like one element of this array. Each, so one thread is indicated, one thread or one element of this array. Okay. Okay. Quick question: why is this also not replicated? Why not 10 copies of this? Hoping you remember what this is. This is what it is. I'm asking why not 10 copies of this in the next program. We use 10 copies of my threads, but not 10 copies of this. Why? Exactly what did mention. Basically, see again what is the function of ATTR? Storing the thread attributes. In this very simple program, we want all threads to have the same attributes. Therefore, we are just fine with having one copy of ATTR. ATTR is storing the thread attributes. So we are in this very simple program. It's fine for us if all threads have same attributes. If you want different threads to have different attributes, you will need to create different copies of that also and pass in the pthread create as needed. Okay. And similarly here also we want every thread to execute the same function. Therefore here we are just passing runner to everything. If you want to change that, I mean depending on your application, you will write different functions. And for while creating different threads, you will specify different function pointers here. Okay. So that's up to you. Okay. And yes, also another change is that now since we are creating 10 threads, we should wait, I mean the parent thread should wait for all threads to complete. Okay, I should not say should wait, but yeah, in this example, in this very simple example, the design is that the parent thread will wait for all threads to complete, child threads. Therefore, pthread join is also called 10 times, and I mean it is waiting for basically every thread. It is the parent thread is waiting for every child thread. Okay. Yeah, and then finally, I mean, when all threads complete, it prints out the sum. So again, this is not a very practical scenario. I mean, this is just to demonstrate some function calls, but I hope you get the idea that like how do you create multiple threads in a program and pass on, let's say, the functions to them and so on. Okay, Abhilash is asking a question, what are the attributes of threads? Let's see if internet can give a detailed answer. So what are we looking for? Pthread attr_t. This is what we are looking for. Okay. This gives a Linux manual page. Pthread attr. Yes, but does it, pthread attr_t is fine, but does it describe pthread attr_t? By the way, what I am doing now, we expect you to do a bit more frequently. That means develop the habit of reading man pages. Some man pages are difficult to read, I agree, like even difficult for us, but at least you should get some idea of what is going on. Okay, here are the list of thread attributes. Okay, if you see scheduling priority, at least these things which you should be able to understand based on what we discussed. Scheduling policy, scheduling priority, stack size, stack address. These are the different thread attributes. Okay. So then, so this man page, I picked it up from internet, okay, but you should be able to get this on your system. Like any Linux distribution gives you automatically the man. Okay. So, like again, if I open up a shell, let me just do one thing. Okay. Man pthread attr init. Okay. Yeah, the same thing. So here also you will get the thread attributes. Okay. So again, I mean, this is in context of what we discussed yesterday when I asked for feedback. So again, I mean, do develop the habit of going through man pages and all. You don't need to, okay, oh, here is a good example also, wow. Okay, so this is one man page which gives you an actual example. So definitely you should look this up. So yeah, as I was telling, develop the habit of going through man pages. I agree that some man pages are difficult to understand, at least some parts, but in general, like those are maybe 10%. 10% man pages are difficult to understand. But in general, man pages are the most authoritative documentation that you can get about a function. So do develop the habit of reading man pages. They are mirrored on the internet, as well as every Linux distribution or Linux distribution will give you man pages. Okay. Okay. Just one small point left about this pthread exit. Right? This pthread exit function. Yeah. So right from the first year you have been using exit, I guess. So there is a difference between exit and pthread exit. So exit kills all threads, including the main thread. So if any thread of yours, any thread on your process calls exit, then not only that thread, but also all threads in that process will be terminated. But if you want only a particular thread to exit, then you have to use pthread_exit. Okay. Yeah. Last. There was a slide on thread attributes. So yes, Abhilash's question could have been answered with this slide also. But yeah, I mean, often man pages are the most authoritative. This slide just gives you some idea, like the system, I mean, the attributes define the state of the new thread. So system scope, stack size, inheritance, and these things. We also saw scheduling policy, etc. These are the thread attributes. So in general, yes, the slides are there, but if you actually want to understand more about the systems than the functions, you should develop this habit of looking up man pages. Okay, so I'll stop here today. Any questions? By the way, I hope you have seen, I'm sure you have seen that the lab assignment deadline has been extended. So it is now Tuesday night, yeah, it was Sunday night. It has been extended by 2 days, so it is Tuesday night. However, on Tuesday, the coming Tuesday, we will have a lab where we will give the next assignment, which we will do after that. But the deadline for the previous assignment has been extended to Tuesday night. But we will have the lab and we will, the plan is to give a new assignment. Okay, any questions? Okay, Ravi has a question. Let's see. Won't different threads have different stack addresses? One of the attributes in that list is the man page. Oh, okay. See, again, this is okay. That's okay. I understand the question. Again, in this program, it is like too simple a program. So that is why we are using the same attribute for all threads. As in general, it should not be so. But I do see your question, even if even if all threads are the same, yeah, I mean, sure, we wanted to execute the same function. Why should stack pointers be the same? Okay. I'm seeing if the man page also gives an example of creating multiple threads. Okay. In the example given in the man page, they are actually changing the default attributes. Like they are using this function to change the default attributes in attr. Fine. But they have also created one thread. Okay. Okay, that's a good question, Ravi. I'll try to clarify this. Maybe this, yeah, I mean, Yeah, this example is taken from the book, but yeah, I mean, uh, I'll clarify this. Okay, because intuitively it seems that if the stack pointer is also a part of the attributes, then if we need to have multiple threads, then the stack pointer should not be shared. I'll clarify. Okay, good question. Okay then, let me stop the class here. We'll continue next week. Thanks everyone.